Hai, Assalamualaikum. Nama saya Muhammad HAKIM bin IZHAM. Nama matrik saya B022-11-0038. Dan lagi sahabat-sahabat saya iaitu DANIAL HAKIM bin Muhammad Jais dengan nombor matriknya B022-11-0030 dan juga Alif Haronudin bin Ismail B022-11-2090. Dan saya ingin membincangkan tentang teori dan juga background. Alright, so saya akan cerita tentang teori dan background. Jadi, eksperimen ni ialah tentang full adder circuit. So, half adder circuit has a major drawback that we do not have the scope to provide carry-in bit for addition. In case full adder construction, we can actually make a carry input in the circuit and could add it with other two inputs, A and B. So, in the case of full adder circuit, we have three inputs, A, B, and carry in, and we will get final output sum and carry out. So A plus B plus carry in equals to sum and carry out. So as we can see, the diagram have shown everything lah. So as per mathematics, if we add two half number, we will get full number. Same thing is happening here in full adder circuit construction. We add two half adder circuit with an extra addition of OR gate and get a complete full adder circuit. So we can see full adder circuit construction, and it is a block diagram. You can see they have half adder circuit A, half adder circuit B, and OR gate circuit. Right. So
now I'm going to show on the codes and the result for task 1. So first thing first, let's see the essentials part of the coding, which is the half adder module and the full adder module. So firstly, the input is AB and the output is sum and carry out. The logic gate used in the coding is XOR AND, same as full adder, but with an additional carry in the input, and the logic gate used is OR, additional OR. So let's take a look at the multiplier 6x6 coding. So the input is A and B, which is both carries a 6-bit value, and then the output is P, which carries 12-bit value. So this is the wire used to connect on the logic gates and inputs. So let's take a look at this pack of coding. So the end from 19 to 24, from the line 19 to 24 is used to multiplication of the first row, which is in the previous drawing, and then the second pack of row is used to multiplication of summation and multiplication and summation of second row, and so on. This is for the third row, fourth row, until the end, which is full adders, used to give the P output. Then let's take a look at the test bench. So the test bench is rack count, which is used to count which is act as a counter, and then the input is register A and register B. So register is used to store the data in the memory, and then the output is P. So for the stimulus, it will repeat 64 times, which is A is equal to count and B is equal to count. For 50 nanoseconds, the count will count up one time, which is will repeat until 64 times. So let's test this, but before that we need to verify the syntax to make sure no syntax error. So there is no syntax error, as you can see. Process behavioral check syntax complete successfully, and then we can simulate the behavioral model. So for the result, firstly, let's zoom out a bit. Okay, so as you can see, from starting point, count is 0, and then up 1 plus 1. Then A, B will also be replaced by the data from count, which is 1, 1. So 1 times 1 is equals to 1. And then 2 times 2 is 4. 3 times 3 is 9, and so on. So this is in binary. For easier for us to read the data, we can change it to decimal. So this shows that the multiplier works.
Okey, sekarang kita berada di part 2. Okey, di sini kita diminta membuat sistem okey, synchronous digit system, di mana sistem tersebut mengesan kata laluan, dan kata laluan tersebut ialah kata berdasarkan nombor metrik pelajar. Dan nombor metrik itu adalah salah seorang daripada ahli kami. Jadi menggunakan nombor metrik pelajar UTM lah. Jadi sekiranya kata laluan yang dimasukkan adalah betul, sebanyak 3 clock circle akan menjadi high. Okey, sekiranya benarlah. Sekiranya tidak, tiada high pada clock circle lah. Okey, sebelum kita lanjutkan, kita akan ke state diagram dahulu. Okey, state diagram ni adalah berdasarkan sistem di mana sistem tersebut mengesan 1011. Ini merupakan dalam bentuk binary. Sekiranya kita mengubahnya kepada hexa, ialah merupakan huruf B bagi awal nombor metrik lah. Jadi nombor kebiasaan nombor metrik pelajar UTM mempunyai 10 digit termasuk B. Jadi ini daripada hexa kepada binary. Okey, di sini sekiranya untuk digit yang awal tu, sekiranya benar dalam bentuk binary ialah 1011. Okey, sekiranya yang masuk adalah 1, ia akan terus ke S2, state 2. Okey, daripada state kosong ni mendapat input dan terus ke state 2 sekiranya betul, iaitu 1. Sekiranya tidak, ia akan looping balik ke atas dan reset semula, dan menyebabkan kata laluan adalah salah dan password yang dimasukkan adalah tidak betul. Okey, di sini boleh lihat ialah kosong. Kosong bermakna bertentangan dengan yang betul. Okey, untuk ke bawah ni adalah yang betul adalah 1. Sekiranya tidak ialah kosong dan akan looping ke atas balik. Untuk daripada stage 2 ke stage 1 ke stage 2 adalah kosong. Manakala stage 2 ke stage 3 adalah 1 dan stage 3 ke stage 4 adalah 1. Sekiranya menempati 1011, ia akan ke stage 4. Okey, start dari stage 4 hingga ke stage 6. Okey, ianya akan memberi output 3 clock circle dalam keadaan high. Okey, dan selepas itu dia akan looping semula ke atas. Okey, sekiranya tidak, untuk yang atas ni ia akan looping ke atas semula lah dan tidak akan ke S4 langsung. seterusnya untuk metodologi. Okey, di sini kita akan create a new project. Lepas tu new source wizard to create a new source and click Verilog module. And then we use a mailing machine to conduct this project. And then the input is 100. Design a Verilog text feature. Lepas tu estimate time in second of string clock circle. Yang tadilah sebenarnya circle height. Okay, after that, after input 100, enter the output logic height for 3 clock circle. Okay. Kita akan seterusnya.
Let's look at task 2. So firstly, let's take a look at the registry module, which is the input is reset, enter, and then set password, and password input is at 40 bits, which is in hexadecimal 10 digits. So the output is access, alarm, and then count, which is 2 bit. It's either 1 or 0, and then wire is check. So the checks is simply assigned to give data based on the set password and pass input. So if those two match, then check will be triggered. Then let's take a look at mode counter. So for mode counter, we set a few parameters for the functioning to work. So the input is clock, reset, and E. So let's take a look at the conditioning. So if reset is triggered, then begin alarm 0 and count back to 0, and then end. Else if E and count is equals to n minus 2, which is n is originally 4, and then minus 2 is 2. If E and count is 2, then the alarm will be triggered, so the count will be plus 1. And then else if count is equal to 3, then alarm will also be triggered. Else if count will plus 1, which is the counter will go up, and then the access and alarm will go 0. And then if any of those didn't happen, it will give access, which is the password is correct to the password to the set password. Password input is correct to the set password. Then let's take a look at the test bench. So module ID test, registry reset, set password for 40 bits, password input for 40 bits, enter, and then instantiate the unit under test, and initial begin, which is the initialized input is reset 0 password. The set password is 40 bit hexadecimal by my matrix number, which is B0221100090, and the input is 40 bit hexadecimal 0. So firstly, reset will be triggered, and then enter, and then the password input will be insert to the correct matrix number. And then a few examples on the wrong matrix number. and then back to the correct matrix number. So let's check this syntax. If there any error, to simulation mode, check syntax. So there is no error, and then we can simulate the coding. Okay, so let's take a look at the result. So firstly, for easier for us to read the result, we change the value from binary to hexadecimal, and then let's take a look at the first password input. So for the first password input, it is 0, and then it is reset. So the encounter start here. So the password input is not the same as the set password, and then it counts as 1. Okay, and then the second encounter, it is the correct password input. Then as you can see, access is high, access is given, and then it resets the count back to 0. For the third encounter, the password input is not the same as the set password. For the second count, it is also not the same as the set password, and also the third encounter is not the same as the set password, which triggers the alarm. So the alarm triggers until it is reset. Then after it reset, the count also be reset to 0 back, and then the count counts to 1, and then the password input is not the same as the set password, which nothing happens to the access. And lastly, the password input is updated to a new data, which is the same as the set password. And once enter is triggered, then access is given, access is high. So the rest of the results is high, access is high. So this proof that the coding works, which is once the access given, it will be high for 20 nanoseconds. Yes. So that's all from our group. Thank you.